Welcome back. Today we're going to look at quadratic functions and models. Remember, there are two ways to write the equations for quadratic functions. The first is ax squared plus bx plus c, and the second way is standard form or vertex form. We do like vertex form because you can easily see the vertex, which is h comma k. For the first example, we're going to derive the quadratic formula by setting the equation of the general form equal to 0, completing the square, and then solving for x. So the equation in general form is ax squared plus bx plus c. When I set that equal to 0, I'm going to now complete the square. The first step is to make sure we divide everything by a, because our leading coefficient needs to be 1 before we complete the square. My next step is to move the constant. So I'm going to subtract c over a from both sides. Now we can actually complete the square. I'm going to look at the term in the middle, in front of x, divide it by 2, and then square it. I'm going to add that product, or that square, to both sides of the equation. So essentially it's b squared over 4a squared. When I factor the left side, I get x plus b over 2a quantity squared. Now for the right side, we can find the LCD by multiplying the top and bottom of that fraction by 4a. And we'll get b squared minus 4ac over 4a squared. It's already starting to look like the quadratic formula. Now let's solve for x. To solve for x, we need to make sure we take the square root of both sides. When we take the square root of both sides, we'll get x plus b over 2a. And then on the right side, it'll be plus and minus square root b squared minus 4ac in the numerator. And then the square root of 4a squared will be also 2a. The last step is to subtract b from both sides. So we get negative b plus or minus the square root of b squared minus 4ac over 2a. So we're getting those two roots. Now let's look at the sum of those two roots. The first was negative b plus the square root of b squared minus 4ac over 2a. The second was negative b minus the square root of b squared minus 4ac over 2a. Now when we add those together, the radicals will eliminate each other, and we'll be left with negative 2b over 2a. And that simplifies to equal negative b over a. For the next one, we're going to find the product. Let me write out these terms again. So we can see when we multiply these, we're actually going to be multiplying two conjugates. The first has negative b plus the square root, and the next one has negative b minus the square root. So essentially they're going to cancel each other out, and we'll have a difference of two squares. So the first term will be b squared, and then we'll have minus b squared minus 4ac over 4a squared. Now those b squareds are going to cancel each other out, and remember that negative is going to distribute, so we'll have 4ac over 4a squared, which simplifies to equal c over a. Now you may remember seeing those earlier. We did have negative b over a. Well, we actually had the positive here, right? I'm just going to put a line there. And then we had c over a, keep moving in and out, as a constant. So you may remember, whenever you're writing the equation of a quadratic, if you have the sum, the equation will be x squared minus the sum of x, and then you could add the product as your constant. The one difference is that you're going to have different values of a that change the parabola, but using the sum and product will help you write the equation given the roots. Now the last thing we're going to do on this example is find the average of those roots. We already added the roots. Remember, we already added it on number 2, and it was negative b over a. If I was going to find the average, I would essentially divide that by 2 because there are 2 roots, right? So this will be equal to negative b over 2a. And that is the equation for the axis of symmetry and the x-coordinate of the vertex. Now let's look at equations of parabolas. We have the equations here in general form, and we want to rewrite these into standard or vertex form. I'm going to complete the square to do that. So the terms x squared already has a coefficient of 1. So my next step was to move the constant. So I'm going to subtract 23 from both sides before I complete the square. So to complete the square, remember I'm looking at the term in front of x, dividing it by 2, which is 5, and then squaring it. So I'm essentially adding 25 to both sides. On the left, that's going to simplify into 2, and then on the right, it'll be x plus 5 squared. So if I subtract 2 from both sides, we'll have f of x equals the quantity of x plus 5 squared minus 2. And that's my equation in standard form, or vertex form. You can see very easily that the vertex is negative 5, negative 2. And the axis of symmetry is x equals negative 5. Now you could double check, because we did find the equation of the axis of symmetry in the first example. Remember, we wrote it as x equals negative b over 2a, and we knew that the b in this equation was 10, and the a was 1. So again, I'm confirming that the axis of symmetry, or the x-coordinate of the vertex, is negative 5. Now to find the x-intercepts, I'm going to set this equation equal to 0. So I have x plus 5 quantity squared equals 2. When I take the square root of both sides, I'm going to have x plus 5 equals plus or minus the square root of 2, or x equals negative 5 plus or minus the square root of 2. Now those are the zeros, but if I'm going to write them as x-intercepts, it'll be negative 5 plus root 2, comma 0, and negative 5 minus root 2, comma 0. The y-intercept will be the value when I plug in 0 into the equation. And it will probably be easier to plug it back in to the original equation. Was x squared plus 10x plus 23. So if I plug in 0, well, it'll be 0 plus 23. And you can see that very clearly that f of 0 equals 23. Now, to make sure we write it as a coordinate, it'll be 0, 23 for the y-intercept. Now, we know that the a value is equal to 1. So this parabola is going to open up and have a minimum. The y value will be the y-coordinate of the vertex. So it'll have a minimum at y equals negative 2. Now let's go to the next problem. For this one, I'm also going to complete the square, but now we have a coefficient of 1/2. So I'm going to essentially multiply both sides, every single thing in here, by 2. So I'll get 2 times f of x equals x squared minus 8x plus 16. Before I can complete the square, well, let's just double check if we need to complete the square. So if we look at minus 8x plus 16, that's a perfect square trinomial. That already factors into x minus 4 quantity squared. Now I just need to make sure I isolate f of x because my a value was 1/2. So now we have the equation in standard form, or vertex form. The vertex for this parabola will be 4, 0. and the axis of symmetry will be x equals 4. When I look at the x-intercepts, well, we could set this equal to 0, but you could probably already tell we already have an x-intercept at the vertex. So if I set this equal to 0, I'll just show it with the algebra. It'll be x minus 4 times squared equals 0. Take the square root, right? So x minus 4 equals 0. So x will equal 4, which again we have is 4, 0, which we found out was the vertex above. Now for the y-intercept, well, we plug in 0 into the original equation. We get f of x equals, I'll just write the equation again. It was x squared over 2 minus 4x plus 8. You can see right away when I plug in 0, well, 0 minus 0 plus 8. So the y-intercept will be 0, 8. Now this parabola has a value of positive 1/2. We know it's going to open up. We also know that 4 is going to be a double root. So that's going to be a minimum when y equals 0. Now let's write the equations for parabolas given certain information. We're given the vertex, which is 4, -1, and a point 2, 3. So if I use standard form, which is y equals a times x minus h squared plus k, well, I do know the x and y. I do know a value for the h and k. The only value that's missing is the a. So I'm going to plug in the values into the equation and solve for a. So 3 was my y. My x value was 2. H was 4. And then my k was -1. So when I add 1 to both sides, I get 4 equals a. And this will be -2 squared, which is, I'll just put 4. So my a will equal 1. So when I write the equation, I'll write f of x. My a is 1, so I essentially don't need to write 1. So it'll be x minus 4 squared minus 1 to show the vertex. For the next example, we have the vertex is -4, 5, so we have our hk. And then we have the point -2, -7, and that'll be our x and y. We're going to plug those into the equation in vertex form and solve for a. So we get -7 equals a times -2 plus 4 squared plus 5. Subtract 5 from both sides, you get -12. And inside the parentheses, you'll get 2 squared, which is 4. So our a is going to be -3. When I plug that into the equation, I'll use f of x. Remember, our a is -3 this time. And the equation with the vertex will be x plus 4, quantity squared, plus 5. For the next example, we're going to write the equation given the x-intercepts. We want to have one equation that opens upward and one equation that opens downward. Well, if we want the equation to open upward, remember the a has to be positive. And if we want the equation to open downward, the a has to be negative. Okay, so if we're given these two x-intercepts, well, we could set those equal to x. Those are essentially our zeros. And to find the factors, we can add 4 to make that equal to 0. Multiply this by 3 and subtract 2 to get that factor. So essentially the equation will be x plus 4 times 3x minus 2. We can FOIL it, so we get 3x squared minus 2x plus 12x minus 8. So essentially the equation will be 3x squared plus 10x minus 8. That's going to be the positive. to find the negative, we're going to have to multiply everything by a negative. So essentially it'll be y equals negative 3x squared minus 10x plus 8. Now there's another way to find the equation given the two roots. We alluded to it in the first example. The shortcut, I would say, is x squared minus the sum plus the product. Now we're looking at the x values, or the zeros. And so we know that the sum of these two, well, that'd be negative 4 plus 2 over 3. Or you can write that as negative 12 over 3 plus 2 over 3, right? So that's going to equal negative 10 over 3. And then the product would be negative 4 times 2 over 3, which will be negative 8 over 3. So the equation would be y equals x squared minus the sum, or plus 10 over 3x, minus 8 over 3. Now those don't have integral coefficients, so you can multiply everything by 3. So we get 3x squared plus 10x minus 8, and you can see that we get back to that equation that we got before. Now for the last example, we're going to look at the max and min of a word problem. So we have Derek Jeter over here, and he has a path of his baseball that he hit is shown with the function f of x, where f of x is the height of the baseball in feet, and x is the horizontal distance from home plate. We want to find the maximum height of that baseball. We could tell it's going to have a maximum height because the a is negative. And we also probably watch baseball or anything that's thrown, right? So there's going to be a maximum height. And to find that maximum height, we're going to use x equals negative b over 2a. So in this equation, the b is 1, and the a is negative 0.0032. So we'll have negative 1 over 2 times negative 0.0032. Now that's going to equal, the negatives will cancel each other out, so we'll have 1 over 0.0064, which equals 156.25 feet. And remember, that's the distance, the horizontal distance from home plate. That doesn't tell us the maximum height. We're going to have to plug that into the function. So f of 156.25 into the equation, negative 0.0032, 156.25 squared, plus 156.25 plus 3. And that's going to equal 81.125 feet. And that's going to be the maximum height of the baseball.